week's worksheet. This week's worksheet gets into a few topics that are very useful to go over before we get into circuit theory itself. They are scientific notation, engineering notation, and Ohm's law. So scientific notation is useful when you have numbers that are very large or very small, because it gets pretty tiresome having to write those out. And honestly, the human eye is not very good at registering how many zeros there are, for example. So something that has this has 10 zeros. So it's better to write it to the 1010, or sometimes there's an E, this type of thing. That's all well and good. In the engineering world, we have our own notation, and they happen every power to the 3. So, for example, if you have something that is 2000, now you could use scientific notation. You could say 2 times 10 to the 3, or you could write that in an even more simple form, which is 2k, because this k means 10 to the 3. Kilo. So I said they go in 3s. So if I had this, for example, which is 2 million, it's 2 M is not for million, it's for mega, but it means 10 to the 6. And if I have 2, 3, 2, 3, and another 3, so that's 2,000 million. That would be 2 to the giga. And you might say, when would you ever use this? Actually, it's used all the time, because in cellular frequencies, which your phones work at, they work in gigahertz. So we use giga all the time in communication engineering. Now I have this 2 to the 10 example in my scientific notation, so you could write that as 20 giga. Okay, it can also go the other way. So if you had 0.002, so that would be written to small m milli. Okay, so this is mega here, which is 10 to the 6, and this is milli here, which is 10 to the minus 3. So what you're going to see getting into these workbooks again and again and again, you will see kilo, because we use kilo ohms, an awful lot of kilo ohm resistors, and because we use kilo ohms, and you'll see in a minute why, we use milli because we use milliamps. And that brings me to Ohm's law. Now, the way I used to remember Ohm's law is, maybe it's a little silly, or maybe it will help you. I remember the top being V, because the top you could almost make a diamond, yeah, and that meant that IR could go here, and it didn't really matter if the R is on the left or on the right, it doesn't make any difference. But that helped me because then I always knew that if I was looking to get current, which is I, that would be voltage divided by resistance. And when you get one, you get the others, right? Or resistance would be voltage divided by current. So this is Ohm's law. Getting back to our engineering notation. If you have something like 1 volt, and typically it's something like 5 volts, or maybe it's 10 volts, something like that. But you could have 1 volt. And you're working in the kilo ohms. So you have 10 kilo ohms. Okay? Well, you're going to have 1 divided by 10. 1, 2, 3. Or let's make that even easier on ourselves. Cheating a little. 1 volt over 1 kilo ohm. We would end up with essentially 1 milliamp. Or if it was 10 kilo ohms, it would be 0.1 milliamps. Okay, now Ohm's law, this is all very nice, having voltage, current and resistance, and this is what we're going to use a lot of the time when we're doing circuit theory this semester, but we can't forget about power. So power is also brought in, so you can have like I squared R, or power can also be VI. So the work, I'm mentioning it here because the workbook does take a quick look at it, and we shouldn't forget about power. But just so you know that when we get into the worksheets and we go through the worksheets, we will be focusing on the relationship between voltage, current and resistance, which is really why you need to know Ohm's law starting this week. And it's also good that you start to get used to engineering notation, because we will definitely be using it this semester. And as you work through the next couple of years in your electronic engineering career, you'll learn more and more engineering notation, so it's good to start getting familiar with it now.